Thanks very much. Any questions which you may have? Can you keep them until the end? Because then we can take a look at them all at the end of the speeches. Let's take a look at the second speech now, shall we? Andrea Antonello is going to present the next speech. He's an environmental degree from Trento University. He's also a co-founder of the hydrologist company. He's also a paparazzi software which is written, which he has drawn up himself. And in this speech, he's going to present to us new tools for gvSIG, for forestry management and hydro-geomorphology. So thanks very much.
Muchas gracias.
My first slide would be, who am I? But he greatly just introduced me. I didn't understand all the parts, but I think it was great. Thank you. So what I wanted to start with is that I really would like to talk to you about JGrasstools. And what is JGrasstools? Just to give you an idea, it's a project that wasn't born yesterday. It started in 2002. And this is more than a decade ago. And it started as under the name Hortonmachine inside GRASS. Maybe some of you use GRASS or know the father of all the open source GIS, and it was a C library in GRASS. Very quickly after that time, in 2003, we started a collaboration with a Jamaican research facility in Kingston and started to develop what would be JGrass. So we wanted to create a user-friendly Java interface for these modules because we found GRASS to be a bit too much academic and not enough user-friendly. So around 2005, my colleague Sylvia and I founded the company Hydrologist based on this JGrass, and we took over the development and the coordination of the project. At that time, we started to look out to understand where to put this library, and in the end, we finished to join with the HEE project, which is another desktop GIS project, and we started this migration to bring all the tools. Actually, it got the Spatial Toolbox of HEE. Everything was going quite fine, and we started to add tools and other tools. Then we added tools for water management and sewer systems. And a couple of years ago, we also added tools to work with LiDAR data in forestry. We had some problems with the HEE project, so in the last year, we started to think to find another community to join. And a couple of months ago, I've been here in Valencia, and I've been helped out a lot by the gvSIG Association to start this migration. And in fact, a huge part of the tools is already in gvSIG. So this is where I would like to start. And the JGrass Spatial Toolbox is another toolbox that you will find in gvSIG under the menu. For the moment, it's called Hydrologist, but it will surely change at some point. So you find a JGrasstools button. If you push that, you get a nice window inside which, on the left, you find a whole pile of modules. It's really a lot of modules. Think of it as the last 15 years of research of a couple of universities we worked with in the past. So you find the modules list on the left side, the parameters if you select a module on the right side, and they interact, obviously, with the layers of the current active map window. And then you can also set some debug parameters or memory parameters. And I think this is a quite important thing that I don't see very often. You can, every time you launch a module, think of the JGrasstools library as a library to make heavy raster processing or use LiDAR data, so huge data sets. When we launch those modules, sometimes things go wrong because it takes more memory than you would have on your system. So the nice thing is every time you launch a module, a different process is spawned out. So you can set the memory and you say, I don't want it to use more than 1 GB of RAM. It will try it, and if it fails, it will not infect your GIS. So it's kind of separated, which makes it quite handy to be used. What do you find inside this library? There are some subsections. The first one is the Hortonmachine, which is also the name with which the library starts in 2002. It's the most important part. It contains a whole pile of modules, like extraction of drainage directions, extraction of the map of slough, attributes of the hill slopes, extraction of watershed basins, the network, a lot of small tools that actually, most probably you find them also in libraries like S6Tante, but these are tools that are necessary to prepare for the use of the real big modules. What kind of interesting modules are in the JGrasstools library? Well, there is a module called peak flow, and this is a module that works for the evaluation of the maximum discharge, so you can calculate the flooding risk for a given precipitation and a given soil type. Or there is a one-dimensional hydraulic model. It's a simplified model based on the equations of Saint-Venant. And the nice thing, maybe some of you know HEE-Crast, but the nice thing, this module is completely integrated in the GIS, and that's cool, because you can work with GIS layers as input, and it will generate the chart in each section of the water depth and the velocity of the flow. And it can also handle lateral input. So if you get water out or in at some point of the channel network. We have also a small module that will prepare the sections of your channel network and export them in a format that you then can use inside of HEE-Crast and directly launch a hydraulic simulation. Another interesting module is maybe the land slope, the hill slope stability module, following the equations of Stahlstab, which gives you the stability conditions of a hill slope for a given precipitation. We have also some modules that work with debris flow. So some of them calculate the triggering of the possibility of triggering along a channel network and how the debris flow would propagate the sediments along the channel network. And there is also, which is now pictured here in this image, there is this module that simulates the final propagation of the debris flow. In this case, you can see the pinkish line area is a real event, and the yellow area is a simulated event, which looks quite similar. It's simulated through this debris flow module. A part of this very hydro-geomorphology related tools, there are a whole pile of raster and vector tools. I won't list them for you. These are tools that are necessary, so small Swiss Army knife tools, let's say. So there can be very simple tools as showing the profile of a shapefile over an elevation model. So you run your shapefile of lines, and you will get back a profile along that line. But there can be also a bit more complex tools. My favorite one is, with no doubt, Bob the Builder. I don't know if you know the character. Bob the Builder is a very, very important tool for people that do modeling on the elevation model. Sometimes in hydraulic modeling, you would like to see how your simulation would go if you insert some structures on the elevation model in the landscape. In this example, you can simply create a shapefile of a polygon, and you put the dots of the elevation that you would like to have in that point, and you can create your very own dam inside of your landscape. And you can do the simulation as if you had a dam, with or without erosion. So there are a lot of tools. In 50 minutes, there's no way to list them all, but just to give you an idea. There is another subsection that's dedicated to mobile, and it's basically connected to another project that's called GeoPaparazzi, and which is an application for digital field mapping on mobile devices. And I'll have a presentation about that tomorrow morning, so if you're interested, jump by. With these modules, you can prepare data or evaluate data that come from your field survey. The newest set of modules is called Raster, which stands for LiDAR Empowered Science Toolbox open source, and has been developed in the last couple of years with the Free University of Bolzano, which is a university in the northern part of Italy, and handles LiDAR data in forestry. Let's say it has been born as a module, as a set of tools for vegetation extraction, but then, as it happens in open source, more and more different tools based on LiDAR data were added. So, for example, if you have your cloud point, your point cloud, you want to extract a digital terrain model. There is a module that's called Adaptive TIN, which is a very well-known algorithm by Axelson, which also, for example, TerraFlow uses to create terrain models, that helps you to extract through triangulations the digital terrain model. There are modules to extract from the point cloud buildings out, to recognize buildings, and this is an example. It works quite well. And then there are modules about vegetation. We chose, in that case, to follow our extraction of single trees from the vegetation. And as you can see, these are examples in this image where the simulation is following quite good what you find in reality. Those work on rasters, but also on point cloud data. The last thing I would like to show you is kind of a mix of everything, and it has been developed during the Summer of Code in 2014 by my colleague Sylvia, and it handles about large wood contributing during floods in the channel network. So you know, when there are big floods, one of the big problems is it takes down all the woods. They finish in the channel network, and somewhere there is a narrow spot. It blocks everything, and the flood gets out. So these are very critical spots, and we developed this small tool, it's a tool set actually, which does simplified two things. It defines how much would the hill slope would be able to contribute to a flood, and then it will also simulate and try to understand how the transportation and propagation of that wood, if it would fall into the channel, would work along the channel network. The result of this is a map in which we identify critical sections, which usually are dams or bridges, obviously, in which we define the volume of wood contribution that could happen during a flood. I think I could go on with this. We have so many modules, I think, for ages, but I will stop here. We have a website for this project, and we now have it inside gvSIG. So I think with the upcoming release in the next month, you will be able to find it, hopefully, on an official website to install. We also have a mailing list, but the gvSIG mailing list will also work perfectly. If you need help, if you're interested, simply contact us, and we'll be very happy to help you out. Thank you very much.